Hello everyone and welcome back to Calculus, the series where we explore derivatives. As always, I'd like to thank all the nice people that support this channel by liking and subscribing. Now, please recall in the last video we utilized the power rule to find the derivative of a function. We also ended the previous video with a challenge. Differentiating 2 minus 11x raised to the 10th power. And it was said that the answer 10 times 2 minus 11x raised to the power of 9 is close but not completely correct. This is because we need to employ one of the most crucial differentiation rules, the chain rule. If we take a look at our example, we can see that this function is actually made up of two components. We have a linear function 2 minus 11x inside the parentheses, and then this entire thing is raised to the power of 10. This is what we call a composite function, or in simpler words, a function inside of a function. If you aren't familiar with this, check out my other series about functions. Here, however, just as a refresher, the notation of a composite function is as such. We write f small circle of g of x. Another more straightforward notation would be f of g of x. In our example, the g of x, or the function inside, would be the linear function 2 minus 11x. And then the f of x would just be x raised to the 10th power. Here, differentiating f of x seems simple enough. It is just 10x to the power of 9. However, here we also need to differentiate the function inside, which is g of x. And here its derivative would simply be negative 11. Once we have all the derivatives, we can formulate the derivative expression for the original f. And that would be 10 times 2 minus 11x to the power of 9 multiplied by the derivative of the inside, which here is simply negative 11. And simplifying this, we just have negative 110 times 2 minus 11x raised to the 9th power. As you can see, here we did indeed apply the power rule. However, what we were missing was the derivative of the inside. And thus from this, we can formulate the formal definition for the chain rule. If y is a composite function in the form of f o g of x, then its derivative would just be f derivative with the original g of x multiplied by the derivative of the inside, or the derivative of g. Another commonly used definition would be dy dx equals to dy over du times du over dx, where y would be f of u and u would just be g of x. Please remember this, it is extremely important. Now that the definition is out of the way, let's take a look at some examples. We are given a function y equals to square root of 4 minus 3x squared. This is a composite function and we can immediately decompose it, where f of x would just be square root of x and g of x would be what's under the root, which is 4 minus 3x squared. Now, looking at the definition of the derivative of a composite function, we know first we need the derivative of f with the original g of x function inside. So let's immediately compute the derivative of f. In this case, square root of x derivative is just 1 over 2 x to the power of negative 1 over 2. However, here, instead of x, we will just put in g of x. And that's equal to 1 over 2 times 4 minus 3x squared to the power of negative a half. And now, once again from the definition, we need the derivative of g, the function inside. Here, g's derivative would simply be negative 6x. And lastly, all we have to do is multiply these two expressions each other. And of course, after some simplification, all we have left is negative 3x divided by the square root of 4 minus 3x squared. And this here would be the final answer to our derivative. Once again, I'd like to end the video with a little question. What if perhaps we were asked to find the derivative of our answer, this fraction right here? Or maybe the derivative of this function. This here would require what we call the product and quotient rule for differentiation. And that's what we will look at in the next video. So I hope to see you there and have a nice day. Bye.